Hi, my name's Mary Wood. Today we're going to talk about slopes and applications of slopes of lines. A slope of a line describes the direction of the line. There are several ways to calculate it. The slope of a line is the small m. One way is to think of it as the rise over run, the change in y divided by the change in x, or there's a formula. If you know the ordered pairs of 2 points on the line, you can calculate it that way. Now let's look at these examples. On this first example, we see, as we look at the graph from left to right, our line goes up or increases from left to right. This is said to be a positive slope line. In the next example, from left to right, my line goes down or decreases. This is a negative slope line. The third example, as I look at this from left to right, notice the line neither increases nor decreases. We say this has a slope of 0. This will always be the graph of a horizontal line. In the last example, looking at this from left to right, notice it is straight up and down, or it's a vertical, sorry, can't spell today, vertical line. In other words, the slope is always going to be undefined. Okay, now let's find the slope of a line given the graph. In this first example, I see I have 2 points on the graph. So remember, slope is rise over run. To get from this point to the second point, I have to go up 1, 2, 3, 4, 5. I have to go up 5 units, and then to the right 1, 2, 3. I have to go to the right 3 units. So the slope is 5 over 3. In this example, let's just find 2 points on the line. To go from this point to the second point, remember it's rise over run is my slope. It does not rise any to go from one point to the next, but it ran 1, 2, 3. 0 divided by 3 is 0, and of course this is a horizontal line. It has a slope of 0. This example, example 3, I want to go from the leftmost point to the rightmost point. I must go down 1, 2, 3, 4, 5 units. Okay, so my rise is a -5 because I went down. My run, I went over 1, 2, 3, 4, 5. -5 over 5 is -1. I have a slope of a -1. Okay, and notice it's a negative slope, so it is a decreasing line. Our last example, let's pick 2 points on the graph. Slope is rise over run. Okay, to get from this point to this point, I went up 1, 2, 3 units, but I had no run, so my run is 0. 3 divided by 0 is always undefined, so I have a slope that is undefined. And of course, this was because it was a vertical line. Okay, let's find the slope of a line given 2 points on a line. Okay, we have a formula, y2 minus y1 divided by x2 minus x1. It's always a good idea to label your points so we don't get them mixed up. Alright, I'm going to write the formula again. Y2 minus y1 divided by x2 minus x1. So, negative 3 minus a 5 is my change in y values divided by negative 2 minus a negative 1. Simplifying, I have negative 8. Now this is a negative 2 plus 1. So I have 8 over negative 1, which gives me a positive 8 slope. Let's label this one x1, y1, x2, y2. Slope, I'm going to use my slope formula that I wrote up here. So 5 minus 5 divided by 3 minus 4, 0 over negative 1, which is 0. I have a slope of 0, so that tells me if I had a graph of the line, this would be a horizontal line because it has a slope of 0. Okay, there we go. I'll write down my formula again. Let's label. Okay, negative 3 minus 5 over negative 1 minus a negative 1. I have negative 8 on the top. Now this simplifies to negative 1 plus 1 over 0. We know we cannot divide by 0, so my slope is undefined. And this tells me this would be the graph of a vertical line. Okay, let's do some applications of lines and their slopes. In this first problem, we want to find the slope of the roof of this house. Now I'm going to be considering this line right here as the slope of the roof. Remember, slope is rise over run. This line looks like it rises 12 feet. And this line only runs from there to there. So it's half of the base of the house, which would be 42. Now if I simplify to reduce 12 over 42, I get 2 over 7. So the slope of this roof is 2/7. Okay, example 2. Here we have a graph that demonstrates the value of a car over time, over years. And we all know that when we buy a car, it depreciates every year in a dollar amount in value. So let's consider 2 points on the line. And remember, rate of change also means slope. So slope is rise over run, or if we use our formula, y2 minus y1 over x2 minus x1. It might be easier to use our formula on this. So let's figure out the coordinates of our 2 points. Let me go down a little bit. The coordinates of this first point, my x value is 2005 and my y value is 20. And on this other point, this would be 2006, 2007 on my scale. So the ordered pair here is 2007, and it looks like my y value is 14. Okay, so we're going to label this x1, y1, x2, y2. We're going to calculate the slope of our line. Remember, it's change in y values. So 14 minus 20 divided by 2007 minus 2005. So I get negative 6 over 2, or negative 3. Okay, this is a rate of change of negative $3,000 per year because our scale was in thousands of dollars. Okay, this is Mary Wood. Have a good day.